Dr. Rob Keefe is our presenter today, and this is one of the Washington Department of Natural Resources programs on forestry that we offer to our foresters and other members of the interested public. Rob, the floor is all yours.
Great. Thanks a lot, Ralph. I really appreciate the invitation to speak with DNR and anybody else who may be watching. So a little bit about me. I'm on the faculty at the University of Idaho. I teach our forest operations classes, general forest operations, roads class, and the cable systems class, and have a fairly active research program now with 4 or 5 graduate students, and also manage the University of Idaho Experimental Forest as part of my position. So it's a pretty fun job. I get to have my hands in research and teaching, and also get out in the woods. We actively manage the school forest with heavy student involvement, typically harvest close to 2 million board feet a year, with students involved in all the planning of timber sales and road work that we do. So pretty fun job. So I was asked to talk today about our real-time GPS work. You'll see in a lot of the slides I use GNSS, and that's just a general term, global navigation satellite system, and means we're using more than just the American GPS system. Where a lot of the devices now pick up the Russian systems and the other ones. So, but for all practical purposes, it means the same as GPS. So, real-time GNSS or GPS positioning for logging safety. Give kind of a quick introduction and some background on how we got into this work, and really today, rather than take a particular study and go through the nitty-gritty details with the methods and statistical results and a conventional kind of science talk, I'll try to hit on kind of the background storyline on how we came to work on this, and then I guess big picture applications and some interesting stuff we found on quite a few different small studies that are going simultaneously over the last year or two, and currently this fall. A lot of that is associated with one larger grant I'll talk about that's funded right now, and we're kind of right in the thick of it. But other parts precede that grant and are more things we've tried on the forest and with managers in Idaho and Montana, Eastern Washington. So, in general, when we're thinking about timber sales, there's the work that the forester does, setting it up. I don't have to tell that to DNR foresters who are listening in, but we spend a lot of time thinking about the cruise volumes and values, roads and other developments that are going to go in. We mark the unit boundaries and the streamside management zones, special threatened and endangered management areas, ARC sites and other special sites, research sites in my case a lot. And we're used to doing that as foresters as kind of a paper plan and eventually getting a paper map, and we're working with GIS probably in the process, developing unit maps and sale maps. But then we eventually hand a piece of paper to a logger most of the time, and then they're going to try to follow those things pretty closely when they're on the ground. And when I was first hired on the faculty, which was 4.5 years ago now at U of I took some time and traveled around North Idaho primarily, and then even came over to Washington and Oregon a bit on the coast, meeting with managers, a lot of the area managers for IDL and foresters, the potlatch offices. I made it over to Green Diamond and some others on the coast, and I was out with Weyerhaeuser, and with all these folks that I visited, I just kind of wanted to ground myself and with the industry in the Northwest and figure out what we could do that would be useful. And one of the things that struck me is I was out on a Weyerhaeuser job and meeting with one of their operations supervisors at the time, and I said, what kind of research can we do here in the next few years at the University of Idaho that would be useful for you? What can we do to help improve operations on the research side? And he said, well, we've had a fatality or two and 2 near misses in the last so many months before I visited that particular tree farm. and those were all associated with cable logging. They were all rigging crews, primarily with belly-choked logs or other issues down in the rigging that had caused accidents. And he and I talked about that a bit at the time, and he said, and you know, we said, well, if we had some way to know where people were a little bit better and keep track, especially when the yarder operator can't see them down over a hill or a blind lead or something, then that would help to improve things. Kind of set me and a few of my grad students off working on some stuff. Of course, we have similar issues. You know, we're usually around 50% cable in North Idaho, and certainly have our share of safety issues here. And so we tried some initial projects with what could we do? Well, maybe if you had a camera on the carriage, on the bottom of the carriage, you could see, you know, where people were and get a better sense for what they were doing, and did some playing around with our little Kohler yarder on the experimental forest here at U of I, and put a camera on the bottom of that. Tried even safety vests and you know, infrared camera and stuff that might show up so they'd be a little brighter and more visible where the rigging crew was if they were near the carriage. And it really didn't work. It just, the carriage bounces around so much, and it's, you know, when it's lateral yarding, it's pulling off to the side, and you're, you know, there might be a person below, but you're seeing the tree line off in the distance, and just really didn't work. So went back to the drawing board and started looking into opportunities for GPS to be helpful in locating where people are. GPS or other kinds of positioning devices, and there's a bunch of stuff coming out on the market. You know, some have been around for a while, like spot receivers. Probably, you know, a decent number of forestry folks are familiar with those, or other emergency locators like the Delorums that are available too. And you know, those are good for locating somebody in a particular situation. And if you're, you know, if you're lost in the woods and somebody you know has an internet connection, they can get on and see where that is. You can also call for help, but it's not really helpful for two machines working on a timber sale, for one seeing where the other one is. Cell phone apps like PDF maps we're starting to use a bit. I know a lot of foresters in our region use Avenza PDF maps on their phones for putting a PDF version of a topo map or aerial photos on your cell phone, and using the GPS chip in it to be able to see where you are, and even unit boundaries and things like that. And that's neat. It's really useful technology. It's coming online and good for a lot of stuff. We're making some new maps for the forest that we can give out to hunters so they know where where research areas are to stay out of and stuff. But again, it's really, you know, you're seeing your own location, but you're not seeing where somebody else is. And that's really what, you know, we'd like to get to for logging safety kinds of applications, and some other stuff I'll talk about in the future. So most of these things, you know, either they're going to require, you know, somebody looking at an internet connection, you know, somebody with an internet connection to see where a piece of equipment is, or a person, or they may be tracking where you are but not where others are, like with PDF maps. So at some point, you know, somebody informed me that if, you know, for hunting, if you spend a decent amount on hunting, you can get things like the Garmin Rhino that have for a while been able to track each other. So you can have, if you have two rhinos in the woods with your hunting outfit, your hunting buddy, you can see where he or she is located on your device, and that's basically two antennas on top. There's one that's receiving a GPS signal from satellites, and the other one is a radio signal that's broadcasting it to the other devices, and then they're plotting those. And so we, you know, that's kind of a step up, because all of a sudden you can be in a remote area and you don't need internet or cell tower nearby, and you can see the location of somebody else that's out there. And these are used a lot. You know, I learned in the meantime that you know, 2/3 of our loggers in Idaho have either either rhinos or alphas that they use for hunting, and so it's kind of familiar technology. So the real advantage there is being able to see where other people or objects are moving around in the woods. And so the alphas are a little bit more capable than the rhinos in what they can do. They can handle 20 hunting dog collars and transmit to a single unit. So if you haven't used these, if you have used these, you know what I'm talking about. If you haven't, it's pretty amazing the first time you try them. You can have this in your hand. It's just like a typical Garmin handheld, and you can have 10 or 15 of these collars out moving around and be able to see them all on the screen there. The other thing that's pretty slick is you can plug these right into a tablet and display on the tablet. Of course, the handheld is kind of small if you've got a bunch of stuff moving around, but you can put them on a tablet or a laptop and have a bigger display, and it'll still display those in real time. And you can put aerial photos as the background or contours or whatever you'd like. Fairly easy to use, and these are fairly easy to set up what are called geofences on. So a geofence is a digital boundary in the woods that, or anywhere you put it really, that will trigger an alert when one of these collars or all of these collars goes in or goes out of it, or both, if in the case, and you can set that. So we did. I was really excited to find these as kind of as a forest operations person. I'm used to taking a bundle of stopwatches and people out in the woods and timing, how long is the processor taking to work through a cycle, how long is the skidder taking to drive out in the woods and come back. And so getting some of these for the first time was really a delight for me, because on the research side, it's made it really easy for us to see where's all the equipment and what's it doing at a given time on a logging operation. And so this technology, we started working with these as kind of the easiest, most available technology that we could get for doing some of this stuff on logging operations, and started, thinking about, well, let's ignore the fact that it's a dog collar for the moment and just try setting up, the boundaries around the harvest unit and hanging a collar on a buncher and seeing if it'll go out of the unit or not, seeing when it goes out of the unit and or goes a little too close to the streamside management zone or things like that. And been pretty well received, pretty fun research to do. A lot of our logging contractors have been interested in it. And so just for example, this is a Stimson job just north of Moscow, and went out with Bob Danielson Logging, who's one of our contractors out of St. Mary's. And this was one of the first times we tried this, and had to convince these folks to wear these one way or another. Some would put the collars on, hang the collars on their belts. Some would put them in a pocket on a safety vest that my wife Maggie sewed. And so we'd have collars on everybody on the rigging crew. He's got one, and then one on a hand faller up here too. And so this is data from that a long time ago now, probably 3 years ago or so, that we tried out with the Garmin, those Garmin collars or transponders, and you can see just for a short stretch of time here, you can see this is the yarder at the top, link belt 98 yarder that we use a lot in our region, and that was strung across the stream in the bottom of the draw, and then you had the hookers working down in the bottom there, and a hand faller up here. You can't see the line very well because he was in one place. But the idea is really, can we set up digital timber sales where all that information that you're used to putting on, working with in your GIS and then printing on a paper map and handing off, could we just hand off a lot of the digital data to GPS units or some kind of GPS system that the contractors are using and have tied in with their machines maybe. And certainly some equipment producers are going that direction. Caterpillar has been very interested in our work with this, and like to know what's going on. John Deere has the Timber Navi software that's coming out, and that's it's working in the same direction, but it's it's still positioning the individual machine, or it relies on a cell service to be able to broadcast the position of a piece of equipment. That's the John Deere Timber Navi software, and it's just not realistic for us to do that in Idaho. I can never get make a call on my cell phone once I leave Moscow. 10 minutes outside of Moscow, we've lost cell coverage over most of the northern part of our state. So you really need that GPS signal coming in, and then the two-way radio signal being used to broadcast the positions around. But the idea is really, could we have a bunch of safety zones for different purposes set up, and/or maybe operational zones that have to do with the timber sale, like the streamside management zone, the unit boundary, things like that. So this, from some of that early work, here's raw data from the Garmin Alpha on that particular sale, just people moving around, displayed in Google Earth or in BaseCamp. At the time, we had, I think, walked around and done these geofences by hand, but typically now we would just do those using a GIS or something and set them up ahead of time. This is a potlatch timber sale, and so all this information really down here, if we look at barriers, gates, special sites, polygons, research sites, eagle buffer, goshawk buffer, class 1, class 2 streams, things like that, all those could be done digitally. Those are their green tree retention areas up there, and the idea is, could we do all those things digitally in the future? And we're working toward that. So there's one of Bob Danielson's excaliners, fairly typical for a lot of the short stretches that we have in our area, and a shovel working down in the draw, grapple skidder coming from the shovel up to a landing. And so this is what the BaseCamp interface looks like here, and we've added some geofences, and so these could be safety zones, but they could equally well be clicking metrics that have to do with production and efficiency in forest operations. And so each time the carriage comes up the hill, for example, if you had a transponder on it, you could click that another turn came up the hill. Each time the grapple skidder comes up to a landing, it could click that a grapple skidder came into that zone up there. And then for our current work, and so we were initially kind of thinking production, but then went down the safety angle, because it just was something that came up again and again, and has been really interesting to see and work on. So typically on a skidder, we'll find just the grating on the windows works great to hang one of those collars on if we're using those. We've had these on dozens of timber sales and still haven't destroyed one, knock on wood. But you'd expect to be banging them up with trees and stuff, and maybe we've just been lucky, but really haven't done too much damage. And that's putting one typically on the cab, and we'll also hang one somewhere out on the boom on a buncher or a processor or the loader. So there, for example, sticking one out on the loader on the back, and even those we've so far not killed one yet. And pretty interesting to see the data that come from it. With the geofences, a year or two ago, we're doing some pilot studies with how accurate are these in the woods. If we have someone walk across a hillside where we've flagged and set up a geofence, we can time when they actually cross the flagging, and then we can time when the alert goes off on the Garmin or other unit, and then look at the time difference. And so for this, one of those preliminary studies, we were 0. It was basically going off, the alert was going off the same time they crossed it, to delayed maybe 5 seconds or so, 5 seconds or less. And that was fairly open conditions on that little pilot study. Another one similar, so had a little go-kart set up on a track at our lab in Princeton, Idaho, and where we do work with equipment a bit, and had it drive across a geofence at different speeds to see how much the speed and the angle affected the accuracy of the geofence, and was kind of an interesting one. You could see the basically at a slower speed, your accuracy is off a lot more. So this top number 5 is miles per hour, kilometers per hour, I guess pretty slow. 5, 10, and 15 kilometers per hour, and you can see there's a lot more variability when you're moving slowly, and we've seen that again studies. So a little bit faster speed, kind of counterintuitive, but a little bit faster speed for a machine driving across a geofence, it actually will trigger just about at the right time. So with some of those pilot studies, we're all kind of on a shoestring, and we were trying stuff out with our equipment on the school forest, and local loggers who'd volunteer some time and stuff, and just seemed like it was a useful topic, especially on the safety side. Seemed to have a lot of support. Our state legislature even voted to give us a little bit of kind of seed money to do some of those pilot studies and get it going. And about that time, in late 2014, NIOSH had a call for the ag, forestry, and fishing safety grants, fairly substantial, large grants, and emphasized logging safety in that year. And so we put in a proposal on this. The first wasn't funded, but when they rejected it, they said we could resubmit it in 6 months if we were interested, and we resubmitted that, and we're successful getting a pretty sizable grant to work on this for logging safety, over $800,000 over 3 years. And so we've got a couple graduate students working on it now, and just are kind of in the thick of it at the moment with a bunch of new field studies we're doing this late summer, this fall, and next summer. And so the phases on that grant are really talk with loggers initially, see what they think about whether this is a good idea or not, what should real-time GPS be used for, or what should it not be used for. And so we interviewed close to 200, interviewed or surveyed about 200 loggers at our LEAP Logger Education to Advanced Professionalism, which is the Idaho logging certification program. I did that this spring of 2016. And then got several field experiments really to focus on the accuracy, where do they work, where does it not work, and what kinds of potential uses are there in safety. And then work on kind of improving the system overall in different ways, develop guidelines for good and bad uses for safety, and that's kind of coming up next year. We're not quite there yet, although there's some real clear fairly clear statements coming out that we could make soon, and then get feedback again from loggers on those kind of proposed safety guidelines, and present the results back through. Doesn't need to just be Idaho. We'd be happy to come to Washington and talk at the safety programs there too, or the logger certification programs, I should say. Some of the things that came up in interviews this spring. One of the ones that jumped out was hand fallers. These basically fall into very specific applications. For example, geofences around a piece of equipment. That's something that requires a very high accuracy. And so if you're going to say somebody's safe or not safe based on how close they are to a piece of equipment swinging logs, then you need to be pretty spot on with where that device is located. And then there are other potential uses that are where the accuracy just doesn't matter as much. Where, for example, if a hand faller is working off around the hillside and stops moving for 5 minutes, there's really two options. Either they're taking a break or eating lunch, or there's some safety issue has come up. They're pinned under a tree or something like that has happened. And for that, it's not as critical that your GPS signal is within 5 feet of where he is. It's that somebody else was able to see that he stopped moving, and they know where the coordinates are, and B, they can get over there rather than waiting till the end of the day and finding out that he didn't show up at the truck or something like that. And so we have kind of those situations where accuracy really matters, and situations where accuracy doesn't really matter. And part of our grant focus is really kind of separating those and saying, well, here's a list of things that it's good for, and here's a list of things that the technology really needs to improve a bit before we can use those applications. Another, a lot of comments in the surveys and interviews about that situation where the yarder operator can't see the rigging crew down below, which is very common for one reason or another with the topography and the stand being harvested. And so a lot of people focused in on those. Certainly much more emphasis on cable logging and ground workers on the ground as opposed to fully mechanized ground-based systems. So for the NIOSH grant, we really just started up less than a year ago, well, right about a year ago, and have kind of been getting situated with some graduate students and what their projects are going to be. The big questions that we focused on so far are really, getting those interviews done, seeing what loggers think. How much do topography and the canopy affect the accuracy of the system? And that's really, there's two pieces to that. It's not really shown in this figure, but there's the GPS accuracy when you're under the canopy. Most forestry folks know that, when you get under a dense older stand, your accuracy is going to tend to drop down unless you have a fairly expensive GPS chip. But there's another piece too. We've got the radio piece too, and so it's kind of an interesting problem because you've got the GPS accuracy that could be off, and then you could be around a hill and the radio signal might not work. So that could be a problem too. And so we've got some studies set up. I'll mention one or two that are really trying to tease out, how bad does the canopy affect either the GPS signal or the radio signal for different systems that are out there. And the other, another important one is topography with, depending on what you're doing, if you've got a geofence around or a position proximity alert around a piece of equipment, how much is that affected by being on a slope? How do they do that exactly in the software for different devices? And when that circle gets flipped on its side, are you still in the outside the zone, or is it distorted in some way because it's on a hillside? So one example, one of our students put this study together. Eloise Zimbelman put this together this summer on the school forest and had basically set up a mobile geofence around a hand faller and set up a course on the forest and had marked all the intersection points along that where if there were a safety geofence radius around that hand faller, like we would think of 2 tree lengths or a typical safety area for a hand faller. What does that look like when they walk by somebody else with a different GPS transponder that's trying to separate the two? And so you've got error associated with this one walking along, coming through the woods, and then you've got error associated with this one. And she was trying to understand a little bit better how that, what are the most important factors with that setup, and kind of interesting data, different from what we expected. These are basically, I know you can't see all the details on the axis, but these are different angles of one walking by the other when the two circles intersect, and the different size of the different radius of the geofence too. And basically what you see in this trend is if you're walking straight into a safety zone, a circle that's a geofence safety zone, then you're going to tend to be fairly close. There's going to be very little difference between when you walk into that zone and when the alert goes off. It's going to be close to 0, and a positive number here means that it goes off a little bit after you walked across the digital boundary. And as you go out to a larger angle, that means basically if somebody were walking right along the side of the circle, right along the outer side of that safety zone, then you get it gets further and further off. It gets way, way off. So this is in seconds, and these delays are 50 seconds off. And it's a negative one, and then what that means is that it's triggering the alert actually before you get there. So it's not as bad a crime as if you walked for 50 seconds past the geofence and we're going into a dangerous area, but it's still really off as far as the accuracy goes. That's 50 seconds, and that happens. We're still scratching our heads a little bit trying to understand the math and the factors behind that, but it happens basically if you're skirting along the edge of a safety boundary, then you get that alert that pops up really early. And again, this is walking at a little bit faster pace, and this is a slower pace. So if you're moving faster, then it triggers. It's less severe than if you're walking very slow or driving very slow in a skidder or something like that. So, but most of that stuff was with the Garmin units, and received a lot of jokes from people about using dog collars for our research. A lot of jokes from company owners about using the shock collar capabilities on the Garmin Alpha dog collar units with their choker dogs and stuff, and had fun with that. But eventually with this NIOSH grant, we've been able to try out some different systems, and that's part of what we're doing as well. And so we've moved to using these Raveon Ravtrack PT units, Atlas PT units that are a little bit more sophisticated. It looks like a two-way radio. It still has a GPS antenna. Can't see it real well, but he's got one on his belt there. It's got the GPS antenna, and then the longer antenna is two-way radio. So it's doing the same thing as the Garmin's, but more functional. These can all send their locations to each other, and so depending on how you adjust the settings on the radios, you can they can all receive everything else that is emitted from a transponder. And if you do that, you can plug in. You can have 10 of these and plug in a little Dell tablet like we do, and all 10 of those can see where everybody else is up to every 1 second. And so that's you can adjust that transmission interval to 1 transmission per second. So just so that's clear to everybody, that means this buncher is gonna receive its GPS coordinate, and it's gonna transmit it every 1 second, and it'll be plotted on. Let's say this were in the processor cab with a tablet sitting on the window. They'll see an update every second. So basically, really in real time. A lot of times people talk about real-time stuff, and it's every 30 seconds or every 60 seconds. This is the real deal. It's every 1 second as that machine is moving around. And another advantage with these is the data are accessible. The Ravtrack software writes all those positions to a Microsoft Access database as they go, and so you can, we have some smart folks who have done custom scripts in basically programming in the software like R, and they can start to set up different kinds of analysis with the logging operation while it's happening. So they can, we can say, well, how far is the skidder from the processor now, and when's it coming in? You can start to write those custom applications, and for you guys, for foresters and forest operations folks out there, you can start to think of all the different applications you could come up with as soon as you have all that data being collected in real time. So we've been using, these are what we're using at the moment on several studies in North Idaho. We've been putting them, we've still been focused primarily on the cable logging with transponders. So the radio we'll put it in a little kind of radio pouch, and typically the rigging crew, the chaser, the hookers will wear those on their belt, and then we'll have a tablet in the yarder cab one in the processor typically, and hang a radio outside each of the other pieces of equipment. There's some real clear differences moving from, I was happy to move away from the Garmins because I was tired of all the jokes about dog collars, but these are pretty spendy. They're very expensive compared to the Garmins. For a handheld radio type like this, you're into almost $2,000 by the time you get to it, and they do have a smaller device that is a transponder made for equipment that would be wired to the battery, and that's less than $1,000, but it's still a bigger investment. And there are some advantages to the Garmins. I'll talk about those in another few slides. But typically this is just a month ago or so on this particular one is Idaho Department of Land's cedar pole sale over near headquarters, Idaho. And this was the first time we were trying to figure out how to put it on a carriage, and ended up, there's a little slot up there that ends up being a pretty good spot on an Eagle carriage where we just zip tie the radio up there, and it's pretty neat to see look at the tablet and see the carriage going up and down the hill, and then see the rig and crew moving in and out closer to that. And so the focus on that analysis is going to be, can we tell how far away the choker setters were from the carriage when it was down the hill, and can the operator in the yarder see how close they are together when they're working down the hill. You can't put it inside the carriage, by the way, because it just won't keep the GPS signal. But for a long-term use, and as these applications develop, of course, it would be just like a talkie tutor. It would be mounted in there somewhere and with an end out the top, like the talkie tutor has. So an advantage of these Atlas PTs, we really have had just about 6 weeks or so getting used to using them in the woods, whereas we had quite a lot of time with the Garmins before that. An advantage is that you have the data accessible and you can do stuff with it as it's being collected, which is huge for lung safety and for different kinds of production logistics applications. The downside, these are 3 sales we've been on over the last 6 weeks. This is let's see, this is that cedar pole sale on the right over here. You can see quite a bit of residual overstory. In Idaho, under state law, on the state trust lands, they need to come in and harvest cedar poles ahead of time separately from the rest of the harvest unit. Once there's a certain density per acre, that's just an old law we've had on the books a long time, and this was a cedar pole sale. So quite a bit of residual overstory in that unit while they're working. This is a potlatch job. It's the edge of a fairly large unit with a Skagit up next to the adjacent stand at the top, and then this is a Excaliner unit on a different potlatch sale out of St. Mary's. These are both in the headquarters area. This is out of St. Mary's, but sitting out in the open of a fairly large clear cut with a slope break out there. We have noticed right off the bat that the accuracy of the GPS on these atlases is actually, I'll be careful what I say because we haven't done a formal comparison, but it seems evident to those of us that have been using the other ones for a while that the accuracy is really affected by the canopy. So the more inexpensive Garmin, consumer grade units you can buy at Cabela's, those collars are $200 and change a piece. Seem to have some engineering in the software that Garmin did that makes them fairly high accuracy working in the woods. That's what they're made for. They're made for hunting dogs going through the woods. Whereas maybe the lineage for these Atlas PTs is they were designed more for construction sites, and it may be just kind of something that something in the how they process the data when it's coming in, or just the GPS chip itself. But in general, we've found right off the bat that the canopy seems to affect these more expensive units more than the Garmin's. And again, we need to do a formal comparison, put them side by side in the same conditions and see what happens and quantify that a little better. But it, for me, it's been fairly evident. Just to show you just a few kind of fun examples. I see we don't have a whole lot of time left, but a few examples that might be interesting to people. Here's a shovel with a harvesting head on it. One of my graduate students has put together a small study to look at if we want to quantify just the swing part with a shovel working, or it could be a processor or another swing machine. How well can we do just using the GPS data to say what that machine is doing as it swings around? And to show you some of the data, these are all actually with the Garmin's a while back. Our goal is really, whether it's for logging safety or production forestry or other applications in the future, our goal is really to be able to hang the GPS on all different parts of equipment, especially if they're the more inexpensive transponders, and be able to interpret those data as they're being collected, and then provide decision support back to equipment operators and to operations foresters in real time as it's happening. So three fun examples here. That's the red and the green here are one of those Garmin collars on the boom and one on the cab of a buncher working, and then the purple lines are the grapple skidder working at the same time. And so, we can't play this back right now, but if you played back these data, you'd see, initially the grapple skidder was coming out, picking up bunches that were on the ground, and then they're coming in, and the same spot that bunch is laid down, the grapple skidder's coming in and grabbing it, and so, one of the suggestions that a friend and colleague over at, or a friend over at Potlatch suggested was, it'd be really nice to have this set up as a heat map, for example, where you can see all the logs. You can basically see the time on the ground that logs have been drying out after the buncher has laid them down, so that the grapple skidder, when it comes up, can just go to the oldest stuff first and get it and bring it out before it's drying. This one is loader and a processor working side by side, and there's a lot of data overlaid on top of each other there. But you could, in these particular conditions, I sat myself and watched on the screen as you could see that processor pick up a log, spin around, bucket, and have the loader grab it, spin around, and put it in the decks. And you can see that pretty well if you stand there with the screen in front of you and the machines behind it. This is another example with a mastication equipment. This was a CAT 315 working on the experimental forest in a mastication study funded by the Joint Fire Sciences Project. And so that was a Dennis brushing head on the top, chipping up small diameter ponderosa pine. And so the green is the cab and the red is the boom, as he'd come up and then work around and chip up trees around to the outside, and then move a little bit and chip some more. So the shovel swing study, this was just a very careful designed experiment that my master's student Ryder Becker did just a couple months ago this summer. Set up a shovel and had it swing around out to different angles with the GPS on the boom to see, at least in a fairly controlled setting, could we tell how well that boom was swinging around. And it's a nice designed replicated experiment. And there's a machine swinging out to different angles every 20 degrees, including all the way around the circle, and had one on the boom, one on the heel, and one on top of the cab, and was able to classify. These are three different transmission rates, one every 2.5 seconds, one every 5 seconds, one every 10 seconds, and at the 2.5 second rate could classify 98% of the swings for swinging the logs out to a given angle, which is pretty good. As you go to a lower frequency with how often the GPS is transmitted, then that drops down a bit. That's what they look like. There's the 2.5 second Garmin collar out on the end of the boom, swinging logs around. There's, as you go to 5 seconds, you can see it's jumping around because it's not sure where things are, and when you go to 10 seconds, it's quite a bit worse. But at the high frequency, it's pretty accurate, at least in pretty controlled conditions. That's just showing all the different angles and how well the different transmission rates could classify that swing as the shovel swings around. So what could you use that for? Well, you can start to think about, there's the safety applications, and we're really plowing ahead with those, but you could also think a bit about production, logistics, for example, with that Montana DNR timber sale data, with the loader and the processor working. This is now, how many times did the processor swing and how long was the grapple skidder waiting? That blue is the grapple skidder bringing turns in. Purple is the processor. How long was that grapple skidder stopping and waiting while the processor was swinging around, cleaning up the landing, getting logs out of the way and stuff? And so you can start to think, well, if that operator knew where the skidder was, they could clean things out a little bit quicker and have the spot ready to go before it comes in, or the skidder could take its time doing something else if they knew that he was still working up here. Canopy, of course, is a big deal. I mentioned we have studies with that. Just real quick, this is 21 stands on the experimental forest where Eloise, master student, is set up. Basically got this triangular plot, looks kind of like an FIA plot. However, she's got radios at each corner of the triangle, and then in the middle somebody walks across a digital geofence, a safety zone. And then we do that thing where we time the actual crossing when it happens and the alert crossing when it shows up for each of those radios on the outside. She's just finishing up collecting those data right now, been plugging away at it for the last month, and should be a really neat data set because it goes from bare bones, recent clear-cut units to thick, older canopy, down, cedar down in steep draws and stuff, and it should be a pretty nice study covering the whole experimental forest on Moscow Mountain here in North Idaho, and get the results from that before too long. In general, to summarize across a bunch of different stuff, I talked about a few studies, but not everything we have going on. In general, very high accuracy applications like a detailed, I need to be 200 meters or more from this point on the ground. We want to be really careful at this point using any of those applications, so a safety zone around a hinfaller or around equipment. We want to be very careful at this point using those applications. However, another part of our grant is looking at what we do in precision farming, precision ag, is to have a very high accuracy GPS on a pole somewhere that's a base station, and that's sending a correction to the one that's on the tractor as it goes through our wheat fields over here. Typically within very, very fine accuracy, very close, or construction, the Trimble units that are on CAT machines used for grading and stuff now are very, very high accuracy. So we're looking at our options for incorporating a base station into all these radios. So you'd have, in theory, high precision or high accuracy on all the radios on the timber sale, and I think that's probably a direction we need to go for a lot of those detailed safety zone type things. So one base station would be correcting all the other radios and getting them a little bit higher accuracy. In general, however, despite saying that, we've had fairly positive response from contractors. They like the fact that it's a tool for them to, for the most part, see each other on the job, as opposed to necessarily beaming the beaming what they're doing back to the boss somewhere in an office. Of course, there are a lot of neat stuff we can think about with processing the data and doing analysis of the data for somebody else. Namely forest operations foresters and managers who are interested in all those details. So, but in general, it's been a positive response, and the biggest thing is really an increased awareness, increased situational awareness for where are the folks on the rigging crew, where are all the other machines when they drive around the hill. And increasing communication. What I really like is kind of that handoff from foresters to loggers with the data that were used to design a timber sale and then are being used to carry it out, and having that in a digital format that can be passed off fairly easily, I think, is the direction we want to go. We expect that with increasing accuracy, as we keep plugging away at that with base stations or other methods, a lot of other new applications will develop quickly. And really, the more you use this, the more you think about all the useful things you could do with it. Wildland fire is a big one. We just a month or two, well, 3 months ago now, submitted a $1.5 million proposal to FEMA, Homeland Security, to really develop the wildland fire aspect. We're trying them out a little bit with our prescribed burning this fall on the experimental forest, but really, if you think of going to a big project fire and having 16 tenders in different areas and 20 engines and a whole bunch of different crews, being able to flip open a screen and see where all those are, as they're moving, as well as the air support. Air support being able to see where people are on the ground. Those kinds of things, I think, it's really a no-brainer that we need to move forward with this technology for wildland firefighting. And we're still hoping to hear in the next few weeks that maybe we were funded on that project, but if not, we'll be trying again with a different proposal soon. I had a lot of support from the IDL and BLM and some other folks who were excited to participate on that proposal, so I'm hoping we get it. If not, we'll try again. Part of that grant was really to do a very careful comparison of not only these systems, but some of the other fancier military grade units that are even, have a little bit higher capabilities, but they also cost a lot more. So a big part of it was, what are the trade-offs for agencies like DNR or Forest Service or IDL as far as what they might use this technology for versus how much of an investment is it going to be, whether that's for wildland fire or for operational forestry. So thanks to some of the many contractors who have helped us out on this, and Potlatch, IDL, Stimson, Montana DNR. We'd love to get over to Washington and work with Washington DNR if you guys are interested and have an interesting place we could try this technology out for safety or for production forestry in the future. Really appreciate everybody listening in and having the opportunity to talk to you today.